Okay, then conversely, we can take some other element y belong to this intersection, that means the other set. Then y belongs to x minus a alpha for all alpha belonging to I. This implies y belongs to x and y does not belong to a alpha for all alpha in I. So here you can see that it's just those arguments in the opposite order. So y belongs to x and y does not belong to any a alpha, that means y cannot belong to their union. Thus y belongs to x minus this union. Which proves that this intersection is a subset of this set, difference of the union. And now we can combine these two relations and have equality. We thus have x minus union a alpha equals intersection of this. Similarly, one can prove the other equality where union and intersection have been switched up, but there are some subtleties in that thing. Not subtleties, but it's not as straightforward. There is a slight change in the arguments. I am going to briefly show how to prove one of the contingents, the other I will leave to you. So now I am going to show this x minus intersection a alpha is a subset of this. This now I am going to briefly argue and show. The reverse inclusion you have to prove and you have to complete this solution. So I start by taking any element, let us take z, in the set on the left hand side. What does it imply? It implies z belongs to x and z does not belong to the intersection. Okay. Now, unlike the previous case, here we have does not belong to, and instead of union we have intersection. So there are some sets, there is some intersection of them. and Z is not in the intersection. What does it mean? It means Z does not belong to some A alpha, because if Z belongs to all the A alphas, it will belong to the intersection. So that's the difference of this from the previous situation. So this implies Z belongs to X and Z does not belong to, say, A beta for some beta belonging to I. That is, there exists some special value of alpha, at least one alpha, for which Z does not belong to A alpha, and that alpha we are taking as beta. But then this implies Z belongs to X minus A beta for some beta belonging to I. That means we have proved that, okay, so if Z belongs to X minus A beta for some beta belonging to I, then Z will belong to this union why? Because there are sets X minus A alpha in this union, of which we are taking the union, as alpha varies over I. For this particular beta, X minus A beta contains Z. So the larger set, this is a superset of X minus A beta, that will also contain Z. So that's why we are getting this, and this proves this containment relation. Now you prove the reverse one, conclude that we have equality, and end the solution. Okay, so with this section 3.4 ends, along with all the exercise solutions. After this we have the fifth section, which involves Cartesian products. But before we go to that, I will go back to algebra. So with that I end this video. If you are new here, subscribe to my channel, A Mathematical Room. So it's me, Lucifer, signing off. Have a nice night.